Hey guys, K2's Retro Workshop again. I can actually play this game because we've got 640 by 480 on this Color Classic now. At 512 by 384, it's a little cramped with all the windows you have to have. Got your long range scan and everything. Anyway, that's besides the point. We aren't done messing with this computer as far as hardware goes. I've got a spicy Overclock here to install, and some surface mount chips came in. I'm going to show you what we're going to do with these, and it is going to involve some soldering. So, here we are. This is our 575 logic board that we've upgraded with the PowerPC processor and everything. Haven't decided where the spicy Overclock's going to go just yet, but we'll worry about that later. What we're really going to be focusing on most of this episode is this guy right here. This is the level 2 cache card for the PowerPC 601 upgrade. If we look at it straight on here, you'll notice what I noticed, probably first thing when I looked at this, is that there's 4 extra pads per cache chip here. These 4 extra pads will allow us to 2 more address lines, which could take us potentially from 256K of level 2 cache to 1 meg of level 2 cache. Now mind you, 1 meg of cache at this time would have been very expensive for SRAM, and that's workstation class stuff that I think we're talking about here. But we're going to give it a try. These chips right here should solder right into those extra spots, and yeah, a guy on the 68K MLA forum already tried this upgrade by just doing a hard swap, and he couldn't get it to work. But I think I know why. I think I know where the problem on that one was. See, this card works without this board as well as with it, without any jumper changes or configuration changes. And if we look at the bottom, there's a bunch of resistor spots here, 0 ohm resistors, and some blank spots. So I've gone ahead and done a little bit of measuring and messing around on this, and it looks like there's 5 pairs. 5 going to low, 5 going to high, and so it's my theory that this down here tells the board what kind of configuration the cache card is. Now, these extra address lines do run to the cache controller and everything, so everything seems to be there to run 1 meg, even though it was never advertised as capable of 1 meg. It was never sold as 1 meg. There are versions of this card for like PDS and such that did come with 1 meg as an option, but not on this particular module. So, we're going to desolder these chips. We're going to go from 32K chips to 128K and play around with some settings on the bottom and see if we can get this guy to do 1 meg of level 2 cache. In case you guys are ever wondering just how long it takes to finish these benchmarks sometimes, this is me benchmarking before we start messing with this guy. So this is without cache at all. I want to have a comprehensive benchmark here for no cache, 256K, and 1 meg, so we can then go into an in-depth comparison about all the different functionalities of the machine and how they're affected by this. And yeah, this disk test is taking about an hour to finish, so, and that's one of only a few I've got to run, so fun times. All right, we got a fairly simple process here. I'm going to apply a little more flux to this guy because it doesn't look like it got very well. Maybe a little more here. Can never have too much, right? Well, maybe. Okay. You may not be able to hear me over the gun, so I'll voice over the rest of this maybe. So there's not a whole lot to really say during here, but, you know, instead of throwing up some music or whatever, here we go. So, yeah, this hot work soldering stuff, I was kind of nervous about it when I first started doing it a couple years ago, but now it's damn near second nature. I just built some 4 meg memory chips by desoldering off of one module and putting them on another. It really does go pretty smoothly, a temperature controlled heat gun. I think I maybe paid $50 for the one that I have, and it has been insanely nice to use. It goes quick too. This video is only sped up 5 times, so it maybe took me 5 minutes to desolder all of this. And the really nice thing about it is the chips are ready to go back on if they need to. There's not really any cleanup or anything. It's pretty nice. And yeah, as you can see here, I've got 3 chips left already. So it was really fast. Leaves you with a clean board too, so that's pretty nice. The really fun part is putting the chips back on there. And as you'll see here, the chips, I used a little bit of solder paste on there, heat them up. I sped this up too, but this does take a lot longer, so I only have the first couple of chips here. It's kind of hard to see sometimes. But as you can see, when the solder heats up, it just sucks into place where it's supposed to, and it's done. All right, so here is the level 2 cache card. All the old chips are right here. So we've got the new, this is 1 meg. I know we're still going to probably have to do some configuration down here. According to that forum post, it should give us a like death bong or whatever when we load this up. But let's give it a bath, and we will tackle that when we get there. All right, so based on other people's experiences, I should be able to hit this power button, and this fails to boot after the swap. No chime. No failure bong either. Okay, so let's move some resistors. So here's where all of our resistors are laid out. These 2 here are set to a 1 as a pair, and these 2 here are set to 1 as a pair. I'm going to leave the 1s alone for now. I'm running under the assumption that it's active high, and that one of these tells the cache chip that it's even got anything installed. And I'm hoping that setting a couple of these over to a 1 are going to tell the cache chip that we have a higher value of RAM installed on this side now. So first thing I'm going to do is move this R6 to R4, and after that I'll do R2 to R1, and then R5 to R3. That'll be all 1s. If that doesn't work, I'll try some other combinations. Won't drag you through all of that. It should be fairly quick though. I got a fun new tool here for moving surface mount resistors. So yeah, I'm going to get on that, and we'll see how many iterations it takes. Here's our cache chip. Sad day in the shop. It did not work. I did all 32 configurations possible on the bottom here, and not a single one of them made a single sound. As long as this is plugged in, this board doesn't do anything. So yeah, even with these chips installed and the stock configuration, I don't get a death chime or anything. So I'm kind of wondering if maybe one of these chips isn't bad. So what I'm going to do is I'm going to desolder all of these and put the original chips back on. And then I'm going to build a tester for these chips. And I want to run all of these through the ringer and see if they're actually doing what they're supposed to. That's going to be some time to get that actually done though. So that's not going to be happening now. But in the meantime, there is another half of this video where we can still speed this guy up. So let me get this back to the 256K configuration so I don't break anything. I've had to take it in and out of this, upwards of 40 times now, and I don't want to risk doing that anymore. If I end up with another one of these Daystars, we'll look a little harder at it. But for now, this hardware change is done. So let's get to that. All right, so to not bore you with the install details here, Spicy O'Clock here set to 37.5 megahertz, I believe. And we've got our wires over here. We get power from where the original oscillator goes, and we lifted the input pin to this clock generator, and we're feeding it with the output from the Spicy O'Clock. So I'm going to get all this thrown back together, and let's fire it up. So here are results. First we're going to go over processor and disk. But top system here is the 72 megahertz overclock for the PowerPC Mystic. That is in the dark green. Yellow is just the standard 66 megahertz. And purple here is the PowerPC upgrade with the cache card removed. And in blue here, we have the Mystic overclock to 36 megahertz, which is about a 10% bump in clock speed. So that's about what it transfers to here as well. And then in red, we have just the standard Mystic at 33 megahertz. In green down at the bottom, I've chosen the 6160 as the comparison system. One, because it's one of the slowest that MacBench 4 does, but also because the 6160 is a similar processor architecture with a very different system around it. So it's got a 64-bit data bus instead of the 32 that we're seeing here. And the perfect example of that is right here on the disk benchmark. On the disk benchmark here, we have our 100% system, and then way over here, we have the Mystic. Now, there's 2, maybe 3 reasons for this. One, these benchmarks should be about tripled, because Mac OS, the version 8 anyway, will default to 96K of cache if the PRAM's been reset, which I didn't notice until I was done benchmarking. And this benchmark took forever at this speed. So, yeah, we are going to just go with the results here and pretend that they're like 45-50%. But even then, at 2 megs of disk cache, we're still at only half of the 6100. The 6100 has a faster SCSI interface and it has a 64-bit data bus. We don't stand a chance of getting to the 6100 speed with the Color Classic. It's just not going to happen. So let's move on and look at our graphics benchmarks. Now, you'll notice that they're fairly even, first and foremost. This doesn't really test the processor all that much. This is more video interface stuff. This benchmark, which I'll put a quick example up on your screen right now, this benchmark is mostly like Excel moving around stuff, Word documents being edited and stuff like that. So a lot of this is just redraw into the graphics buffer. And since the 6100 has nothing but a frame buffer either, it's not like it has a nice, ATI accelerator or anything for graphics. It's pretty similar in performance here. Kind of shocking that the 68040 can keep up with everybody else, but hey, that's the benchmark. It is what it is. We can see that the no cache here is spending a lot of time taking up bus time, transferring to and from memory to get stuff done that neither of the other processors really have to do. The 68040, it does have to do that, but since it works in 32-bit chunks, it's a lot faster at going to grab something real quick from memory versus the PowerPC. Now we're going to scroll down a little bit, and we are going to look at the cinematics benchmark. The first one here, 100% on almost everything except the no cache. This is a little like 160 by 120 maybe video that plays with sound. It's very simple. It's very small. Not super surprising here. Same thing here. It's maybe 320 by 240 is I think the size it goes to. But it was able to play almost everything. So we were good there. Where your real difference comes in is here, where you've got motion JPEG versus uncompressed. Now on motion JPEG, we see about like our processor scaling, maybe not quite as bad, but it looks to me like this is just a clock speed issue as far as the 68040 goes. We're at almost 9 here on the Mystic at 36 megahertz versus almost 18 on the 72 megahertz PowerPC. So here it looks like it's just a clock speed. If you were to clock double the 68040, it should be up here. It just doesn't have that ability. And yeah. Anyway, What we don't expect to see is the result here for the uncompressed. The 68040 is almost 50% faster than the PowerPC. Now, my theory on this one is similar to the difference between, say, a PowerBook 100 and a Classic 2. The PowerBook 100 and the Classic 2 both run at 16 megahertz, but the PowerBook runs a 16-bit processor on a 16-bit data bus, while the Classic 2 runs a 32-bit processor on a 16-bit data bus, a lot like a stock color Classic does. And I've noticed that if you take the same zip file, say like a 3 meg compressed file, and you go to uncompress them at the same time, the PowerBook 100 is actually about 50% faster. And I believe that's because when the PowerPC processor is doing a data move, it has to move 64 bits of data at a time. So a lot like a 386SX or a Pentium Overdrive on a 486 system, this system ends up having to do 2 transactions, 2 transfers to move from memory to cache or to registers before it can then send that 64 bits on down the stream, in this case to the video buffer. The 68040 doesn't have to do that. It pulls 32 bits and it puts down 32 bits. It pulls 32 bits and it throws out 32 bits. And that overhead and data transfer gives us a huge advantage in on-the-fly, uncompressed video playing, because this processor doesn't spend a bunch of time waiting for that next 32 bits. It can just do what it needs to do. And yeah, that's my theory. As to why the no cache has better performance in this than the 256K, if someone else has a theory on that, I would love to hear it. I cannot figure out what is going on here. So, yeah, let me know. But those are our benchmarks. So, let's talk about what we learned here. All right, here she is. Not as exciting of a video as I thought it was going to be, so I should be able to cut out a lot of frivolous stuff. It might be a short video. But I did order some SOP sockets that I have in the bag here so that I can make a carrier for these RAM chips and I can test them. I have a feeling at least one of them is bad. It just acted that way when it came to trying to get it to work. I will approach it a little differently next time. Instead of trying to desolder and move resistors, I'm going to just put some switches in there. So I can shut it down, flip a switch, and fire it up again. I've not given up on the 1 meg thing. That is going to happen. But yeah, overall, this is honestly a surprisingly pleasant system to use. My Classic 2 model, it's basically a Classic 2. It's a color Classic with the LC550 logic board installed in it. And it's a really nice system to use, and I really do love that thing. But this has been a real pleasure to use. Helped a lot by the fact that I can take this like Mac cubed shovelware stuff and literally play any of the software on any of those discs. So you've got hundreds of software packages here to play, tons of games. Hell, there's 4 CDs between the 2 of those of just games to play. And there is so much that you can do that, bane of my existence growing up was always, you need a 68030 to play this. Ugh. And then you get one. And then you see a cool new game, you need a 68040 to play. You need a PowerPC to play this. And this machine is able to do a lot for what it is. The CRT I still want to replace because I don't particularly care for how the 640x480 ultimately looks on it. It works for now though, so I'm in no rush on that. But should one come up, I do want to get that swapped out. that being said, I've used this a surprising amount. Like I said, I can run dang near anything that I want. And it's been a really fun machine to use. So I do plan on revisiting this once I figure out why the cache doesn't work. I ordered these chips and they came from China, so for all I know, they're not even SRAM. So when I get that figured out, we'll come back to this. I'm fairly confident that I can do 1 meg of level 2 cache in this guy. So yeah, until then, if you have any questions, comments, anything that may help me reach the goal that I'm looking for on this, let me know in the comments below. And thank you for watching.